This problem says a quarterback throws the football to a receiver downfield at an angle of 40 degrees to the ground. It is caught by the receiver 2.5 seconds after it is released by the quarterback. Assume that the ball is caught at the same height from which it's thrown. What is the initial velocity with which the ball was thrown? What was its highest point in flight? How far downfield did the receiver have to catch the ball? Make sure to use position, velocity, and acceleration versus time graphs to describe the motion. So here I set up a drawing of what happened when the football was being thrown, and I set this as the X and this is the Y, obviously in the positive directions. And then the time is 2.5 seconds. Then I set this up to find V initial in the Y direction and V initial in the X direction. And then here are my graphs. The position goes like this, and then velocity is in a negative direction and acceleration is constant. So this is the knowns, the gravity and the time. So I just plugged it in to find the V initial this time. So and then in the Y direction equals 0. So then I just plugged it in and I got V initial equals 12.25. And then in order to find the maximum, I divided the time by 2, so the time is now 1.25. And then in order to find this, you have to find the V initial of X, and that is in order to find the maximum height. So I did the cosine of 40 equals V initial X divided by 12.5. And yeah, and then I got the horizontal equals 9.38, and then we're trying to figure out X. So we plug this in, and there was no acceleration horizontally. So after that, I got 11.5. So the initial velocity is 12.25. The highest point is 11.75, and the downfield is 23.45. And I found that from plugging it back in with the time.